Hello, so I'm recording this video for the hackathon of building next generation AI agents with RangoDB, cuGraph, and NetworkX. So my idea is about a crime reporting tool, particularly when in cities or countries. I came across this really beautiful blog, and it was talking about he said that everything is related to everything else, but near things most people related more related than distant things. In fact, if you read this blog post at some point, you will see he says that the reason why we end up having whiteboards like this with connections and linking between things, he says it's because human beings, we visualize things as networks. So with that, I came up with the idea of getting this crime reporting tool, and the data, it came from the data comes from the NIBRS crime data. I will be providing all the links to the GitHub repository too. So but I will go ahead and explain what I did. So first of all, I didn't find a better way to import the data, so I used the adapter from I saw documentation from 2022. And given this is a multi-graph, it's not a single graph with just a pair of nodes or a pair of relationships. It's a multi one, and it's going to have a lot of relationships and entities. It was quite challenging in the beginning, but I managed to do it. So after I got the data, I decided to model it, and the best model I could come up with is these nodes: crime location, the crime type, the person, the neighborhood, the district, the premise. So the neighborhood where the crime happened, and person in this case is the victim. Now, after I create the knowledge graph, I passed in a custom controller using the adapter from Arango, and once my data was loaded, it was now easy to get it via the Arango driver, the Arango NX driver for NetworkX. Now, for sample data and visualization, I'm just going to display that. Great, so here it is. Here we have a premise. It seems like this place, it's where crime happens a lot. The yellow node, it's the crimes that have happened. The green nodes here are locations, so they seem to be happening at different locations. The purple one is the crime type. So, and the pink one is the person of the victim of that crime. So it seems here like we have this crime type. It's called AGG assault, and it seems to be the one at the center of everything here, and just by analyzing we can be able to tell either this is a group of people or someone who is pattern is to just do this kind of assault, and you can see there are so many crime linked to that. Yeah, so this is just a sample visualization of the graph, so I'm just going to walk through the code. Now, to walk through the code, I want to think of it this way. So I'm using multi-agent system where I have a supervisor agent. The supervisor agent basically takes in the question and decides where to go. Now, it's not a direct flow because I'm having agents communicate with one another from one point to another. So in order to achieve that, I had to create tools, transfer tools. From LangGraph, there is a documentation you can look for how to do handoffs between agents so they can be able to communicate with one another. Maybe an agent does something and then it finishes it. It wants to pass some instruction to another agent to finish up the flow. Now, this supervisor agent is best to visualize it. Now, this supervisor agent is the co-orchestrator. It's the entry point to our workflow. However, once we get in, we decide whether we are calling which tool, whether we are transferring. So I have the profile expert, the one that goes to the database and it can do profiling, it can query the database and find out what is it, the actual data, what is it we want to search for. So the network analysis expert is the one that uses Network X, cuGraph, and RangoDB together to analyze our network, do some analysis, then come back with some results. It can also transfer to the profiling for further queries, and a reporting expert that this basically summarizes our conversation after we are done, and then it gives us a general report. So as for the analysis, the network analysis, I just followed the code from the previous notebook given by the hackathon team. As for the network expert, the text to SQL, I'm using the Rango QA chain, but later we will visualize we will also get the SQL, and we can be able to visualize maybe the graphing and see the connections between our nodes and relationships. So the profile experts is currently connected to the database directly, so it is able to go to the database and find some answers. And then there is a visualized graph that returns graph elements that we will use later to display on the front end. Now, so my workflow is pretty simple. I have the supervisor, and since I'm using this command, I don't have to specify from one edge to another. As long as I have the commands, I'm having agents communicate with one another in a complex network, which can be visualized here. So here it is. You see there is a lot of connection. The expert goes to a tool, and then it can answer to itself. It can send back the two answers of the tool to the profile. Then after that, we can go to the visualize network, and then we can end. And then we have the network expert, which can go directly after it's done. It can go to reporting or profile or a visualization tool. So it's complex, but this is a multi-agent system where agents communicate with one another to provide better output for the user. So it's better than using tools. So just a sample question: Are there demographic patterns amongst victims of specific crimes? If so, do visualization. For now, the visualizations will be stored in the visualization data graph element, which will visualize later in the front end. So you see it's creating a cipher a Rango query, the AQL. It gives us some response from the tool, and then we are able to answer from that. Okay, now on to my front end. I decided to use a React and the LangGraph React package. So here I'm trying just to communicate, and I'm logging out what is happening in the background. So I'd be happy to analyze demographics, and I need to transfer you to the profiling expert who specializes in demographic analysis. So it transfers to the profiling expert, and then now he analyzes the patterns, and then given from the analysis we can get some few insights, and then now we can receive the answer. So notable patterns: common assault shows most diverse victim demographics, and this is basically supposed to be crime investigative tool. So it should help law enforcement agencies to analyze large networks in real time. This data is it's not real time yet, so I got it from here, and it has also geospatial data, which means we can be able to narrow down our results if let's say we needed to look for a particular crimes in a certain radius. So this is my basic app. I'd like you guys to look at it, try it, and I really hope you like it. Visualization is underway. It will be as soon as possible. So the visualization of our network will be somewhere here. Okay, so by the time you guys get this code and you try it, it will be already there. So thank you. For those who are looking to look at my code, I will be displaying it in GitHub in a while. Thank you. So now to the code itself, I used LangGraph hosted, self-hosted, to be able to host it. So the entire code in the notebook is also found here in the in a LangGraph development, where you can use LangGraph CLI to host the agent, and then in the front end we can use the React SDK version. So yeah, so I will also be uploading all this code to the GitHub. Thank you for taking your time to look at my presentation. I hope you like it. It's not much, but I hope you like it. Thank you.